9.5, polar coordinates, what you should learn. Plot points and find multiple representation of points in the polar coordinate system. Convert points from rectangular to polar form and vice versa. And then convert equations from rectangular to polar form and vice versa. So before today, all we ever worked with was a rectangular system. We had a rectangular coordinate system, which is like this, x and y. The points were x and y. And we went x and y. X left and right, and then y up and down. On a polar system, in a polar system, it's actually going to do r and theta. A lot of times you see rings, and that's your radius. A radius of 1, a radius of 2, a radius of 3, and go on so forth. So if I give you 3 and 120, that's a polar coordinate. We know this is 90, this is 180, 120 is over here somewhere. We're going to be on this pole, the 120 pole. And then we're going to go, what's the radius? The radius is 3. We're going to go out 3 from that spot. So 1, 2, 3. So that would be 3 and 120. R is the directed distance, what radius do you go? And then theta is the directed angle. How much of an angle do you want? And we're going to do r theta. So we're going to plot some points on the polar coordinate system. The polar coordinate system, you really just draw a normal one, and a lot of times we draw concentric circles. And I'm actually not doing too bad on this one. Something to that effect. Oh well, I'm going to copy and paste it for the rest. Okay. So that's how you draw a polar. You just get a rectangle and add circles to it. Now, r is 2. We're going to get to this middle ring here. And then my theta is pi over 3. Pi over 3 is essentially 60 degrees. So if this is 90, this is 0, or pi over 2, pi over 3, so over here. But our real answer is the point right there. That is 2 pi over 3. All right, we go to angle of 60, then we go to a pole. That we're going to hit the pole of 2 from the radius. Okay, the next one, 3 and negative pi over 6. So negative pi over 6 is a negative 30. So it's going to be over, we're going to go from 0 down 30. Remember, when we're negative, we go down. So we're going to go down 30, so we're going to be like this. It's an estimation. We'll set the negative pi over 6. And then we have a radius of 3. We're going to go 3 out from the center on that pole. 1, 2, 3. So right there. And the next one, 3, 11 pi over 6. 11 pi over 6 is probably the same spot. We go, this is 6 over 6. This is 12 pi over 6. And then 1 less. So same spot, and we're going to go 3 right there. Okay, before we move on, we should have another point. We should do the point negative 2, and we'll do 11 pi over 6 again. Let's talk about what that does. We'll do it on the same graph. Let's graph negative 2 and 11 pi over 6. So what happens to the negative 2 and negative radius? We're going to still be on the same pole because it's still 11 pi over 6. Let's continue this graph all the way. And when it's a negative, we're going to go back to 1, 2. The point right here would be the point negative 2 and pi over 6. So that's how negative radiuses work. So you go back on the pole. Positive radius, you go forwards toward the pole, toward that angle. A negative, you go backwards. A negative angle, just a normal angle. Positive, you go up. Negative, you go down. A negative radius, you go back on the pole. Next, multiple representation of a point. We want to plot this point, and we want to come up with 3 additional polar representations of this point. Okay, so negative 3 pi over 4. So here's 0. Here's negative pi over 2. Here's negative 4 over 4. Negative 3 pi over 4 would probably be halfway through this. So we'll say that. I could do better than that. We'll say that is the pole for negative 3 pi over 4. We haven't got to here yet. We're a little short. Negative 3 pi over 4 is right there. And then 3 would be the third ring. So that guy right there. That's a normal one. That's what they gave us. We want 3 other representations of it. The first one, just directly. What's this in the positive angle? You could do a closure angle. You could add 2 pi to it. But let's just look at it. If we're doing a positive, this would be 4 over 4, 5 over 4. One of them we could do 5 pi over 4 and 3. That'll be the same thing. We go 4 over 4, 5 over 4, and then go 3 from the center. Now let's do a fun one with a negative radius. I did this backwards, by the way. The radius goes first and then the angle. There we go. What if I want to go from here, but I want to go backwards? I need to figure out what angle this is. Well, if this is 4 over 4. This is in the first quadrant. This will be pi over 4. I could do something like pi over 4 and then negative 3. We go to this side, but we have to go back 3. 1, 2, 3. Okay, for a third one, let's try to go double negative. Let's go negative angle and then negative going back. I want to go all the way back to here. Let's go negative this way. This will be negative 4 over 4. Negative 8 over 4. One less will be negative 7 over 4. But then around this pole here, we want to go backwards 3. 1, 2, 3. Negative 3. Those are 3 different representations of the same point in polar. We could do a lot more. We could do coterminal angles up the wazoo. Keep on going round circles. But those are some general ones. You could go negative angle, or you could go negative pole, or normal angle, normal pole. Okay, coordinate conversion. We want to convert from one to the other. If we first start off with r and theta, how do you make that into x and y? So we actually just have to use SOHCAHTOA in the triangle. You can make it a triangle, and all I need is the x value, and I need the y value. Well, we could do SOHCAHTOA. Cosine of theta would get me x over r. Sine of theta will give me y over r. And if you solve that for x, and you solve this for y, multiply both sides by r, you get this formula. X equals r cosine theta and y equals r sine theta. If I give you a polar and you want the rectangular, all you have to do is plug into this formula because it all comes from making a triangle. Make a triangle and basically solve for x and solve for y. If you're trying to go the opposite way, if you have x, y, and you want r theta, we got to find two things. We got to find the r. If you have an x and y, you have this point and this point. How do you find the r? Pythagorean theorem. X squared plus y squared equals r squared. Now you can solve that for r, square root both of these, all that stuff. And how do you find the angle? If you have x and y, that's a tan. So we're going to have tan of theta equals y over x. And that's how you find r and theta. You have to do a little more work, but you're going to find theta from here. So you can do tan inverse both sides. You can find r from here. You have to square root both sides. But that's the general process. It all comes from making a triangle. And then here's the general formulas. X equals r cosine theta, y equals r sine theta. The one thing about tan theta, I will say, little asterisk, you got to check the quadrants. Because tan inverse only works in quadrant 1 and 4. If you're in quadrant 2 or 3, you're going to have to add either pi or 180 if in the wrong quadrant. Because tan inverse doesn't get you those quadrants. You got to watch out when you do tan inverse. You have to make sure first plot your point, make sure it's in the correct quadrant, because if it's over here, you're not going to be able to get it. You have to add 180 or pi from one of these things. But if you're in the correct quadrant, you're good. The first one, convert this point to rectangular coordinate system. So this is my r, my theta. I want x and I want y. If we know the formulas, x is r cosine theta, y is r sine theta. Cosine always goes to x, sine always goes to y, sine e. Now we're going to just plug it in. So this is going to be 2 pi. I get 2 cosine pi. I'm going to get 2 sine pi. Let's figure out what pi is. Here's 0, here's pi. It's on the unit circle. So that's negative 1, 0, x and y. Cosine is x, so that's negative 1. I get negative 2. And sine is a y, so 0, I get 0. So this is the same point as negative 2 and 0. And let's check. Here's my polar system. If we graph pi and 2, pi would be over here. Here's 0, here's pi. Then we go 2 out. So right there is pi and 2. If we do a graph on the rectangular system, here's x, here's y, would go left 2, the exact same spot. It works. Okay, let's convert this point to polar coordinates. I'm going to need r, and the formula for that is x squared plus y squared equals r squared. Polar is r theta. And in theta, we have tan of theta equals y over x. Remember, tan is always a slope. Slope is always y on top. The first one, plug it in. So we have negative 1 squared plus 1 squared equals r squared. We get 1 plus 1 equals r squared. The 2 equals r squared. Square root of 2. We're always going to assume positive because we do a polar. Tan inverse. So we have tan of theta equals y over x. 1 over negative 1. So we tan inverse both sides. You could use a calculator. You actually shouldn't need to. When does tan equal negative 1? So theta is going to be negative 1 is down here. Tan inverse plus and minus. That's going to be 45. Negative 45 degrees, sorry. Let's put negative pi over 4. It doesn't matter which one. Remember what I said before, you got to check, make sure it's in the right quadrant. Is that in the right quadrant as we need? Because right now we're in quadrant 4. Negative 45 is in quadrant 4. Is that point in that quadrant? Let's graph it real quick. And we get negative 1 and 1. That is up there. So you can see it's not in the correct quadrant. That is not where negative pi over 4 is. Negative pi over 4 is down there. So it's an easy fix though. All you have to do is go back here and add pi. Or if we're doing radiant degrees, you would add 180. Because that's how we go from where we're at right now, which is down here, or right there, to over there. You just add pi or 180. That's all it is. So it's an easy fix. Anytime it's wrong, you just add pi, and you get it right back again. That's over 1, so 4 over 4. I'm going to get 3 pi over 4. That should be my theta. My formula is going to be, my coordinate point is going to be r, which is radical 2, and then 3 pi over 4. And there's lots of ways to represent that. Okay, last little part here. How do you convert the equations? Now, one of them is really easy. Going from rectangular to polar, super simple. All you have to do is, wherever there's an x, replace it with r cosine theta. Wherever there's a y, replace it by r sine theta. You can see here's an example here. So replace them, and you get this. And then you can just do some trig identities that we all love to get something like that, get r by itself. So it's super straightforward. On the other hand, going the opposite way, if you have polar and you want rectangular, it's a little more, you do a little more work. Describe the graph of each polar equation, find the corresponding rectangular equation. So we have to keep in mind that the equations we have to use are this. And tan of theta equals y over x. This first one here, r equals 2. What I could do is I could square both sides. And I get r squared equals 4. And now why did I do that? Because r squared is x squared plus y squared. So I could replace this with x squared plus y squared equals 4. And you get your equation. That's a circle. B is a little tougher. I have theta equals pi over 3. I can't use this first one, that doesn't help me, but this one does. What if I take the tan on both sides? If I take the tan on both sides, I can make this guy look like tan, and I know tan of theta equals y over x. That's what we're going to do here. For this one, we're going to take the tan on both sides. So we get tan of theta equals tan of pi over 3. So I took tan of both sides, tan of theta, tan of pi over 3. This guy equals y over x. Just following the formula right there. Tan of pi over 3, we can figure that out. Pi over 3 is a 60-degree angle. Rad 3, 1 and 2. Tan is opposite rad hypotenuse. So rad 3 over 1. Right here, we have equal signs, so we can just cross multiply. I get y equals rad 3x, or x rad 3. And that's our equation. That's just going to be a line with the slope of rad 3. So there's that one. Okay, how about C? R equals secant theta. So the next one's probably the least intuitive. You got to bring out the other formulas too. X equals r cosine theta, and y equals r sine theta. Going this way, you're going to try to use these to figure out what we get. Right over here I have r, but squaring both sides and changing it to x squared plus y squared, but then on this side I have secant squared, which I don't think it's going to lead me anywhere. But what I could do is that I know secant is kind of like cosine. What if I do this? I make r equals 1 over cosine theta, and then I can multiply this to both sides. I can multiply cosine to both sides, and then we get, cancels out, we get r cosine theta equals 1. But r cosine theta is just x. Yeah, that's what r cosine theta is. This is just x equals 1. And that is a line. So that's how you convert from polar to rectangular. You have to play around with it a bit. Going the other way, going from rectangular to polar, if I gave you this, you just change x to r cosine theta. Done. We have to get r by itself. Over here, you change x to r cosine theta, you change y to r sine theta, and play around with it a bit. Anyway, that's the lesson.